Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
We are back at SMTA International 25. This is a Decode Podcast. We are here with Chelsea Jewell, Application Lab Manager from Kyzen. So just selfishly, we all love Kyzen so much. Every time we talk to anyone from Kyzen, we have a hard time, not just like gushing about you guys. But before we start, why don't we give you a chance to talk about Kyzen and what you're doing here and how you specifically help them at Kyzen.
Absolutely. So I have been with Kyzen a little over 13 years. I rolled right out of college into there and haven't left. I started in our application lab, just running testing, trying to figure out. Honestly, I walked in, a chemical engineering background. I walked in, I was like, why are we putting electronics in water? I feel like that's bad.
Great point.
That was baseline where we started. Working up through the lab, it's been a fun ride. Like I've done, the customer visits, we've gotten people to come into the lab. And I think that's my favorite thing is we're problem solvers at the end of the day. Flex cleaning, it's simple at this point. Like we've done it for so long. What gets really complicated is the technology that's involved and how everything's moving so fast. The materials are changing. So keeping up with that is always a lot of fun.
For the longest time, I just used isopropyl. And then I got a batch washer and my eyes kind of opened up to, oh, wow, this is actually really nice, And then also like we'd have to like scrub, right? Like crazy.
Right.
Yeah.
Well, and there's such variability in that type of process too. You're like, am I tired? Is this person going to actually pay attention and get all this off? It depends on like what that's going into as well. Like there's definitely different bars.
So do you work in like one specific area of the cleaning side? Because you guys have a lot of different products. So I know we use like a reflow cleaner, like a wave solder cleaner, the stencil cleaner, the actual chemistry we use for our batch machine also. So are you kind of just all across the board, or are you focused more in any certain area?
So Kyzen, actually, we do cleaning products for almost every industry that cleans. So we are in military, aerospace on the metal side.
Yeah, like automotive and stuff.
Yeah,
too, right?
automotive. Looking at the really tight particulate specs. The really cool thing that came from, COVID, we had a lot of, parts issues, like supply issues. So automotive reman really kicked up at that point, because if they can pull a warranty repair engine out and clean it to get somebody back on the road, we have a whole process line set up for that. So I kind of do it all. With that, I've had like the top rotor of an Apache helicopter come into the lab, which was super cool.
That's cool. Yeah.
We had like 50 millimeter shells, which was a little terrifying.
You're like, these are inert, right?
Thankfully they were blue. But I all the way down into like the cases for pacemakers. So it's really widespread, but it's still super technical.
And that keeps it interesting though, right?
It does. I've had hockey pucks come in, they misprinted it. So we took the ink off of those. You never know what's going to show up, to be honest.
Well, what was the wildest to me was at the SMTA, not Dallas, because I didn't go to that one.
That one was so good.
Oh,
Good.
the cleaning and conformal coating symposium. Yeah.
Is that the STAR?
Yeah.
The
better one. The one that if you're going to go to one a year, that's the one you probably go to. I didn't go to the Dallas. That's why they love it. But
you did.
Yeah.
You did.
I was in Dallas. Yeah.
We met in Dallas.
We did, yeah.
But one of the things that surprised me the most was Mike Conrad during his presentation that said, I would rather you not clean it all than clean bad.
Yeah.
And it kind of blew my mind a little bit. And then he started getting into the reasons behind it.
Mm-hmm.
I was very shocked to see that, right? Because I thought like, you're just throwing it in the dishwasher. If it works, right? So after that presentation,
Well,
I don't have a Rose test. I don't have a CERT test machine, right?
Okay, yeah.
So I have no way to know. You know what I'm saying?
Absolutely.
Right? I have no way to know other than visually looking at it and then whether it comes back after a failure, right? So that's the only way I knew. But really blew my mind on that. I don't know if I can't be the only one in this world to not have thought that way too.
Yeah.
Is there any way you could like expand on why that is?
So in the, nomenclature of no cleans, and this, it's a controversial topic. Everybody hears about cleaning no cleans. When I started, we had a meeting with a customer who's having issues and brought the solder paste company in, because it's always better to have that network and have everybody who has a stake in it involved. And they were like, the solder paste guys go, why are you cleaning a no clean? And there was like dead silence for a little bit. And you're like 90% of what we clean are no cleans, because in theory, those ionics that are in there, as you're going through the reflow oven, everything's going to be inert at the end of that. And that's saying your printing process is perfect. Your reflow thermal profiles are perfect.
Well, not just that, right? Like something, not to give Conrad too much shine here, but like one of those things he said is it's not just the solder paste flux residue that you're not cleaning if you're not cleaning. It's everything else that could potentially be there, right? Like any other type of debris or
the decision
residue.
not to clean flux is the decision not to clean everything.
Absolutely, yeah. You going back to your bare boards, your board fab, those plating baths can get off, and that can spike certain materials, and they're all ionics at the end of the day. So you have some risk with that.
Right.
But yeah. So partially clean, you've kind of cracked the outer shell of that flux at that point. So you've exposed everything. So some understanding of how clean is it? My favorite thing to do, and it makes everybody who builds electronics cringe. I rip the boards apart. I want to know where that flux is. And you can actually, we take chisels, we take X-Acto plates, we rip them apart. I had a very expensive board, and they were high reliability. They couldn't have flux on there. So I was like, I'm going to take a chisel to this board and rip it apart. And he's like, what do you mean? But when you open that up, especially your large format components, you actually see the flow paths that the chemistry took. And what it can tell you is hey, we're getting there. We just need a little bit more time. But not seeing that, you're like, no, we're fine.
Yeah.
Kind of deal. So a lot of people, either they don't want to know, which that's everybody's choice, or if you start popping those components off, it tells the story for sure.
So you mentioned that cleaning is relatively routine for you all now, since you've been doing it for so long. But I have to imagine that there's some kind of contemporary challenges, right? Particularly with these low standoff, bottom terminated components. Yes, for certain that your chemistry is going to do the job it needs to do when it gets into contact, right? But
how do you get the contact?
How do you
need?
how
the force?
Yeah, exactly.
It falls back to education a lot. I get that question more commonly now than I ever have. When I started talking about design to clean 10 plus years ago, they looked at me like I was crazy. I was like, no, really, I can build you this process, but we're going to take it so far out of bounds that it's going to be a pain point. It's going to slow your production down. And you're like, why? If we take these steps, you can get back to an easier process.
So it's one of the things we saw in Dallas, right? Definitely. The design principles you can incorporate to actually assist with cleaning. It's not, that DFC. So you can do different things. What all the things we saw? Silk removal, or adding silk in some places actually helped in cleaning in certain shapes and geometries.
Raise the ceiling and lower the floor, right?
Yeah.
Create these paths
with masks,
the chemistry to ingress and regress.
With the way you design your mask around your pads and everything.
As a stencil guy, I hear that and I get a little right? Because we're changing the surface of the board. I don't want,
Yeah.
So, but and I think to your point, that's why it is important that everyone who has a stake in this whole process, we need to collaborate, communicate. Because what might be good for
that could solve one thing for cleaning and may make printing much harder if you don't take that into account. That's true.
True. Well, and that's something I really strive for when we're trying to make these changes. Is some people, they're like, well, just change the solder paste. You find an easier solder paste, and you're like, it has to print right, it has to reflow right, and then it has to do its job.
Yeah.
So I feel like that's the easy thing for us to fall into, but it's not the right way to go about.
Yeah, absolutely agree.
Kind of bypassing all root cause analysis at that point. You know what I'm saying?
Yeah.
Then you kind of just crossing your finger, hoping the new one changes it.
Yep. Well, knowledge of components. That's crazy right now. Talking about widening that gap. Also looking at the bottom of the component. I've got, some that are molded plastic, so they've got indentations in the bottom of the component. So if you have if it's fully flux dammed under there, you're never going to be able to get up in those protrusions and everything to clean it. You're like some awareness of that.
And what's the danger in that? If you've left that contaminant or residue in there, what can happen later from having that there?
As they're getting into the field, you're going to have heat fluctuations. You're going to have humidity fluctuations. It depends on if you're coating. So if you're coating over that, it cannot adhere properly. You could have moisture ingress at that point. You start to get electrochemical migration with those, and that's where you start to see your failures.
And so a lot of people kind of foolishly or naively think that coating just kind of fixes that and make sure it'll never happen. But if you actually coat over something that isn't cleaning up, like depending on a lot of variables here, but just a general statement, if you're not cleaning over not clean all that residue off before you do the coating, you can still have dendrites grow underneath the coating.
Well, thank you so much for being on here. And I hope the show goes great. I'm actually coming back to your booth later on today. Debbie posted or Kyzen posted, you guys have a demo going on right now?
We do. We have our Analyst2 on there. So what its job is to tell you what concentration your bath is running, but it also gives you some metrics. So if you have,
like it gives you like a digital number?
Yeah, absolutely.
Okay.
Yeah. So it's a quick read. It's accurate typically to about 0.1%,
Good
which
enough.
is really fun. It's really cool technology. So you have some traceability, you have some visibility into what's going on with your cleaning process.
I'm excited to see that.
Because right now, I'm sure you probably have to do it the same way, where you periodically just have to manually mix the stuff in, see what color, like how high the color separates up on the little.
We have this new one with it's like a sugar test, I think they called it, kind of.
With the pink reagent?
Yeah. So mine's different now.
It's a split test. Yeah.
It's actually so much easier.
It
It's
is.
1,000 times easier.
Were you doing refract before?
Yeah, I don't know. Debbie hooked me up.
Okay.
Put the tops on, and then
And you were saying you put your finger in it and just touch it to your tongue, and you could kind of tell that way.
I mean, that's obviously
Like
the
with
most accurate
batteries,
method.
like those 9-volt batteries.
there's the warning labels, but maybe.
They're that calibrated. That
Yeah, yeah.
yeah.
CTAC calibrated taste buds.
Yeah.
I think your soil loading's at like 2%. Like,
Honestly, I mostly go by I think it's called the resistivity meter on my batch washer.
Uh-huh.
And once that thing starts taking a while to regen, I know we got to do a clean out, right?
Yeah, that's
So-
fair.
And then also like the way the concentration bumps in, as long as I'm full and nothing changed and deviated with either the wash getting too much or diluting too much, then it's going to be
But what you have over there is a continuous monitoring, like at all times. It's just telling you what
Gives you some real time process control.
It does. So, it is retrofitted on pretty much every batch washer on the market right now. It can go in line. And what it does is it goes in line with the wash pump. And so that flow pattern, we've got a special fixture that goes in the machine. So you keep the flow pattern going through the tuning fork correct. Because that's a big factor as well. Like, if you have a weird swirl or something in there, if you don't have it moving right, setting that up is critical. Having that visibility with the batch washers, you can see real-time concentration, temperatures, any of those diagnostics you can pull off of it and chart real time. Everybody loves data. So
Yeah.
you're like, we can tell you the temperature, we can tell you, my fun thing that I've done with it recently, we did a research project trying to figure out how our products, our next gen mix in the machine, because that's always critical. Talking about the split test, we got to mix them. So I have the Analyst hooked up to one of my batch washers, and we just run cycles and we chart and see, with this amount of time before, letting it rest and everything, how that all mixes. So I get to use our tools too, which is it's a fun thing.
it's like a validation for your actual machine, right? Because I might plug in, I want it at 140, right? But it actually might be coming out colder, hotter, depending on what's going on in the environment. So
Yeah.
it's pretty cool.
Depends on where the thermocouple is with it too. You're like, if that's reading my tank temperature, once it travels into the chamber, is there a delta there?
Yeah.
I'd love to see your guys' lab. Like I have this mental image of it. I actually just want to see it. Like should probably make that happen.
Yeah.
Well, I mean, Nashville's super fun, but the lab is open. I mean, we've got a lot of machines. It's a kind of a playground. So
Yeah, it sounds like it. Like, I can see like your eyes just light up a certain way when you start talking about the lab.
Yeah, right. The playground.
I get to have fun with it. Like I get to solve people's problems and we have fun. I think one of my favorite things, as you move up in your career as an engineer, you do less engineering, you do more managing.
Yeah.
So as people come in trying to solve a problem, most of the time it's those that are coming into the lab to see what's going on and to fix a problem because they have a problem. But then they get to get their hands into something, and
Yeah.
like it brings back that energy that you had as a young
Yeah.
engineer. I really enjoy it.
Start taking chisels to boards.
That's right.
$1,000 boards. Ying.
Yeah. I mean, I got some looks, but it was like, I'm going to solve your problem.
Gotta learn, right?
Yeah. It's like I told you it's a destructive test, but you know, at that point, like we ended up shifting how the board was in the machine because the flow path going under that component,
Okay.
it was blocked. So just that knowledge and that visibility, you could solve a problem.
Amazing.
Well, Chelsea, thank you so much for your time. We appreciate everything Kyzen does for the podcast and for us as customers. And just thank you again. I hope you guys have a great show here at SMTA.
Thank you guys
Thanks,
for having
Chelsea.
me.
As a stencil guy, I hear that and I get a little, right? Because we're changing the surface of the board. I don't want,
Yeah.
So, but